Hi, fans. Welcome to our Lecture 2 lesson. Please kindly subscribe to my YouTube channel at Waniswakem. In this lecture, we are going to determine the empirical and molecular formulas. Example 1.1. The empirical formula of a compound is C2H4O. Determine the molecular formula of the compound, given that the molecular mass of the compound is 132 and preambles has been given. C is equal to 12, H is equal to 1. So we are going to solve this example. So the empirical formula of a compound is C2H4O. So we have a relation that molecular formula is equal to N times empirical formula. But our empirical formula is equal to C2H4O, and our empirical mass is calculated as 2 times carbon is 12 plus 4 hydrogen is 1 plus oxygen is 16. So our total mass will be 44, which is equal to 44. But molecular mass of the compound so molecular mass of the compound is 132. Similarly, we know that our molecular mass is equal to N times empirical mass, N times empirical mass, and then our molecular mass is 132, which is equal to N times empirical mass is 44. So we will divide both sides, so we get 132 is equal to 44, divide both sides by 44. 44 will cancel 44. So 44 goes into 3. So our N is equal to 3. So N is equal to 3. And our molecular formula is equal to N times empirical formula, but N is equal to 3. So our molecular formula is equal to 3 times our empirical formula. It is C2H4O. So our molecular formula becomes, we multiply 3 by 2, so our C will be 6, our H will be 12, and O will be 3. So this is our molecular formula. Mm, Therefore, molecular formula of the compound is equal to C6H12O3. Our next question. Our next question, that's example 2. Find the molecular formula of a compound that is 40% of carbon, 6.72% of hydrogen, and 53.28% of oxygen by mass. And preambles has been given. Carbon is 12, hydrogen is 1, oxygen is 16, and the molecular mass of the compound is also given is 180 gram per mole. So this question, we will find the molecular formula for example 2. So we will start. Suppose we have 100 grams of a compound. Suppose we have 100 grams of the compound. Suppose we have 100 grams of a compound. And then that is 100% will be equal to 100 grams of the sample. So based on the question, our mass of carbon is 40.00%, which is equal to 40.00 grams. A mass of hydrogen mass of hydrogen is 6.72%, which is equal to 6.72 grams. Mass of oxygen is equal to 53.28 5%, which is equal to 5,328 grams. So this is step 1. So step 2. Step 3. So step 2, we will convert these masses to their respective atomic weights by dividing each of their masses to atomic weight or mass. And then more precising, so our number of moles will be calculated as we have our carbon atoms, hydrogen atoms, and oxygen atom. So based on our calculation, our mass of carbon is 40 divided by atomic weight or mass of carbon is 12. And mass of hydrogen is 6.72, and our atomic weight is 1. And for oxygen is 53.28. Our atomic mass is 16. Based on the answer is 3.33, 6.72. Then here is 3.33. Step 3. Step 3. Divide through by the lowest, and hence we will have 3.33. So 3.33 is our lowest. 3.33 6.72 over 3.33 and 3.8, sorry. And we have 3.33 over 3.33 So here our answer is 1 and our answer here is 2 and here is 1. So this implies that our empirical formula for C is 1 and hydrogen is 2 and our oxygen is 1. Therefore, it can be written as CH2O. So this is our empirical formula. To find molecular formula, to find molecular formula, we use MF is equal to N times EF. But molecular mass of the compound will be given as N times empirical mass. This is our empirical formula. So our empirical mass. So empirical mass of CH2O will be given as 12 plus 2 times 1 plus 16, which is equal to 30. So our molecular mass will be equal to N times empirical mass. But in the question, molecular mass is M. Molecular mass is 180 and empirical mass is equal to 30. Therefore, our N will be equal to molecular mass over empirical mass. So 180 over 30. From this equation, that's where we derive this equation. So our N will be equals to 6 because 30 goes into 6 times. So our molecular formula will be N times empirical formula. So our molecular formula is 6 times empirical formula is CH2. So it is C6H12. 6 times 2 is 6. This compound is glucose. So our example 3, the empirical and molecular formula may be determined from experimental data. Suppose we have a compound containing the elements C, H, and S. When 7.96 milligram sample of this compound is burned in oxygen, it is found to form 4.544 milligrams of carbon C. The sulfur in the 4.31 milligram sample of the compound is converted into sulfate by a series of reactions and precipitated as barium sulfate. The barium sulfate was found to have a mass of 11.96 milligram. The molecular weight of the compound was found to be 168 gram per mole. Using this data, what is the molecular formula of the compound? The preambles has been given, so we go to our working sheet. So this is our question. And our answer is the compound contains, this is our preamble, the compound contains C, H, and S. And then our compound contains C, H, and X and S. So and the molecular mass has been given. Molecular mass of the compound is equal to 168 gram per mole. 160 gram per mole. Therefore, when 7.96 milligram of sample of this compound is burned in oxygen, so the total mass of the compound. So total mass of the compound is equal to 7.96 milligram and mass of the, and then mass of carbon C is equal to 4.544 milligram. So we can find percentage of carbon. The percentage of carbon will be equal to 4.544 milligram over the total mass is 7.96 milligram times 100%. So that milligram will cancel milligram. Our final answer is 57.10%. So we now have our percentage of carbon, but the only source of sulfur from the question is barium sulfate. The only source of S is barium sulfate. It's barium sulfate, but molecular mass of barium sulfate is equals to 137.39 plus 32 plus 4 times 16. 132 is the mass of barium plus sulfur is 32 from the question, and then oxygen is 16. So it's oxygen, there are 4 atoms of oxygen, 4 molecules or atoms of oxygen. So our barium sulfate will be 233.39 milligram. If 233.39 milligram of barium sulfate contains 32 milligram of sulfur S. Then then 11.96 milligram of barium sulfate will contain 11.96 milligram over 233.39 milligram times 32 milligram of S. So it will, the final answer is 1.640 milligram of S. Note 4.31 milligram of the sample was converted into barium sulfate. This means that this means that the sample contains 1.640 milligram of S. Therefore, percentage of sulfur will be given by 1.64 milligram over the total is 4.31 milligram times 100%. So our percentage of sulfur will be 38.05%. Now, we have known our percentage of carbon and sulfur. So to determine the percentage of hydrogen will be 100 minus percentage of carbon plus percentage of sulfur. So 100 minus percentage of carbon is 57.1 plus 38.05. So our percentage of hydrogen will be 4.85%. So we now have our hydrogen. So back to our calculation. We have C, H, and S. Percentage of carbon is 57.1, and hydrogen is 4.85, and sulfur is 30.05. In step 1, this is step 1, we have known our mass for each element. And step 2, we divide through by atomic weight. Atomic weight for carbon is 12. Atomic weight for hydrogen is 1. Atomic weight for sulfur is 32. So 57.10 over 12. We have our answer to be 4.76, 4.85. 1.19, and divide through by the lowest. So the lowest is 1.19, 1.19, 1.19. So here our final answer will be 1, and here will be 4, and also 4. So our empirical formula. Our empirical formula will be equal to C for H for S, and empirical mass. Empirical mass will be 4 times 12 plus 4 times 1 plus 32, which is equal to 84. And then molecular mass is equal to N times empirical mass. But from the question, our molecular mass is 168, which is equal to N times empirical mass is 84. So 84. We have 1, 6, 84, and 84, 84. So 4 N becomes 2. Therefore, molecular formula will be equal to 2 times empirical formula is C4H4S, and then you will arrive at C. 2 times 4 is 8. H 2 times 4 is another 8, and S is 2. So this is our molecular formula.